Good morning, everyone. Welcome to this webinar. My name is Jessica with Mileside Marketing Department. Later, I will walk you through some very interesting information about the remote I/O devices in the IoT world. For some of you, maybe this information may be a bit of a refresher, and for some other guys, this may be all new, so I will try my best to provide information that is equally comparing to both groups. The first thing I want to say is that there's no particular order or there's no particular level of importance for each of these factors in your choice, and each may be a deciding factor in your purchase. And I will cover each of those 4 factors or features individually, but here is a quick recap. First, there are more choices in terms of the networks than ever before, which is great for allowing you to deploy a network that meets your speed, meets your cost, meets your power consumption needs than ever before. And some people are not so familiar with input-outputs, making them one of the most underused things in the IoT devices. So this is a shame, as they can provide some great information very easily, and we will tell you how. Depending on how well you manage the data that collected from the I/O devices. Anyway, we should find the most easiest way to check, to read data, and how easily you can trigger the device to perform on other devices according to your threshold settings. So we hope you can find a user-friendly platform to achieve both of them. And what reasons will decide the quantity that connected to a remote I/O device, and you may find even LoRa and cellular can support different quantity of the end devices. Well, according to the breadth of the network offerings in terms of offering different price points, data throughout space, and power consumption levels has been growing a lot in the past few years, and this has made choice more confusing. Okay, so hopefully this slide can help you to break it down into to better understand the third or totally 3 categories. The first group is the high-speed cellular offerings, which would include 3G, 4G, and 5G very quickly. And for those who are very concerned about speed, this I think this is only group to consider. It provides the speed that rival that is available, what is available in many business, and enough speed to allow for the real-time solutions. The downside of these faster networks is the same downside of buying a car with a very big engine. You are going to pay more. This is going to use more gas, or in case of the controller, it means more power. So this makes these devices not ideal for the deployments that are powered by batteries. And the low speed cellular options are starting to merge, starting to develop, and will power the expected explosive growth of the IoT more than any other group. Cat 1 offers the most speed of this group, and allowing for enough bandwidth to download data quickly in applications like the digital signage. And Cat M is the most recently launched one, recently being deployed in most areas of North America and many other areas of the world. It's ideal for the applications that need a reliable connection but aren't all about speed. And finally, NB-IoT will be the optimal choice for the extremely cost-conscious customers, for the budget-limited customers, although networks won't be ready for bid. And the wide area non-cellular is a category that is relatively new, but has become very popular for some certain segments. The low-power networks like Sigfox may prove their popularity in checking and monitoring the low-cost access better than the existing technologies. As well, many different city like officials or regions are using the LoRa equipment to provide a reliable method of talking to remote access that does not use the internet. So, according to their development, the Sigfox and LoRa one, they will tell us how popular they can be in the future. And in Ursalink, you can find the high-speed 4G LTE band, you can find NB-IoT band, and also the finally LoRaWAN based remote controllers. And without a doubt, one of the most underutilized portions of an IoT device are the input and output ports. The interfaces, they can be used to gather many key pieces of information. So what are they? First, inputs are used to take in either an off or the on and off signal or reading a key items. Examples may include how many times a door has opened and what level of the water or grain is in a storage container, or how many marathon runners have gone past a particular distance maker. And the outputs are a bit different, as it originates from the IoT device and a signal is sent to a device. So it may be to open a key door, such as a door at a remote secure location, so you want to remote control it. So there are two different formats of input and outputs. Usually you can see mostly digital and analog. First, let's see digital inputs. Digital inputs have only two states. They are on or off, similar to a light switch. In the case of a marathon runner, input can be received from a motion sensor, a laser beam that is broken by the runner or when they step on a particular mat. So that signal is then sent back to the server. Then you have the analog inputs. They work on various ranges as opposed to on and off status, so different from that. So they are able to work with other sensors to determine the level of key things, such as the amount of the grain inside one of these containers. And GPIO. GPIO is a type of pin that found on our integrated circuit that does not have a specific function. The function of a GPIO pin is customizable and can be controlled by the software. These pins act as a switch that output is only 3.3 volts when set to the high frequency and no voltage at all when set to the low frequency. So due to the small voltage, usually GPIO interface is used to trigger a component instead of directly connect with a sensor. So usually we don't connect the GPIO interface with a sensor. And one of the most common types of outputs available is the relay output. A relay can be used with both AC and DC loads. For instance, it can be used to control the turn on and turn off of engine heater in winter time due to high voltage range. So relay output, it can be used to control a big device or big voltage device through a small voltage. And the serial port RS-232 and RS-485, they are widely deployed in the industrial applications, but they are much different in much different working mode. RS-232 is currently deployed in a wide range of low data rate, short-range applications. Cable lengths are typically less than 50 feet. So common equipment include like the low-speed models and industrial controller equipment like the programmable logic controllers, or we can call PLCs, and computer controlled machine tools like CNC machine tools, and embedded control computers, medical instruments, and many more. RS-485, this interface is also widely used in industrial applications, while the higher speeds and the longer distance are needed. So it is used in the same type of equipment as defined for the RS-232 interface. And you can also find some POS, the point of sales terminals, and the metering instruments, and those kind of devices can be connected to the RS-485 interface. And the networks defined by the field bus, like the Modbus, use this interface as well. So now we understand the most popular ports or interfaces in the IoT world. So let's see, what can we use after you power on the device, after you power on the controllers? How can you read the data? How can you read the data directly? And how can you realize the remote control? That will be a question. Do you want to find a platform to test their performance quickly and easily? And if you are using mild-side IoT cloud platform, then you can reach the hundreds combination of the condition and action, the trigger, the advanced rules engine that function to easily control the connected devices through the I/O controllers. And how many sensors, how many devices that can be connected into an I/O controller? This is frequently asked question, as we know usually the quantity is the same as the number of the input interface. So if there are two digital input or analog input interface, then it means two devices can be connected. If there's one RS-232, then only one device can be connected. And for the RS-485 interface, it's a little different. For example, the LoRaWAN-based UC500, okay, when it works like in the if-then command, the maximum 4 units of the temperature and humidity sensors can be connected at the same time. Well, if this controller works only as a conduit or a transparent method for the data forward, okay, then it means 10 units of the temperature and humidity sensors can be supported at the same time. So the quantity of the connected devices reliant on their working mode. If it works as a conduit or it carry on the if-then commands. So it depends. In mild-side, as I mentioned, you can find the controller device that either based on cellular, based on NB-IoT, or based on LoRa, different network, okay? And the mild-side UC3 series, this series I/O controllers are offering the high-speed cellular like 4G, 3G, and 2G, and the low-speed cellular like NB-IoT. It's designed for the indoor usage only because you can find the IP rating is IP30 only, and they can be acted as a TCP/IP device. The serial interface, the UC3X52, that model can monitor or control the I/O devices through the Modbus TCP protocol. So you can find the Modbus master or Modbus slave mode. And by the way, these models are 3 different models, okay, coming with different interfaces, like the different 2 digital input, 2 relay output in the UC3X14, this model. There's no analog, no serial port. So that's what I want to share with you guys here. And next is our UC11 series. These series are designed in the same hardware platform as the cellular, the UC3 series based, but it offers the wide area coverage based on the low power consumption network, LoRaWAN. So it contains different I/O interfaces such as the analog input, digital input, relay output, and the serial interfaces. The only difference is the LoRaWAN based, okay? And by the way, you can find we have certified CE, FCC, and FCC and Korea certification in Korea if you want to import the products in Korea. And for the configurations, I want to say those UC3 series and UC11 series, they are support the USB configuration, okay? You can download the toolbox and take use of the USB port to connect with your device for the configuration. Well, next is our UC500 series. This is our new version, the exactly new version that upgraded from the previous UC11N1. If you are visiting our new website right now, you can find these 2 models. They are also LoRaWAN based, the long range, low power based. But what's the difference? First, it contains different I/O interfaces, such as the analog input, serial port, but GPIO interfaces. And besides that, another unique feature is the solar panel design. So customers can choose to use either battery version or this solar panel version. You can find the front panel. This is the solar panel, and you see 502. This version is the battery version only, okay? But you can also choose the DC power as well if you want. So the protocol Class A and Class C, because UC501, this model can support the solar panel or support the battery, so it can switchable. The Class A and Class C is switchable from the software. And okay, let's see what's our unique selling proposition. So after powering those kind of controllers, you can directly realize the remote control by the MileSight IoT Cloud, MileSight IoT Cloud platform. For example, if you want to turn on or turn off the light, or turn on or turn off the music, or the HVAC system, or air conditioning, well, you can fully take use of our cloud platform and take use of the digital input-output interfaces in the controllers to connect with the third parties system to triggering or interfacing with other systems. And I want to emphasize the Modbus bridge. The Modbus bridge feature in the UC11 and the UC500 because it can convert the serial-based devices into LoRaWAN-based devices and enables data transmission between the serial network and the TCP/IP network over LoRaWAN protocol. Okay. And also we can support this Azure and AWS platforms. They are very famous platforms for supporting data in the cellular network. And also AWS has the platform AWS IoT Core for LoRaWAN. That's a new network or new platform that we are going to certify as well. Here are some recent examples that can made by our developers, made by our customers with our controllers. I think the controller can be used in every environment where the I/O equipment needed to monitor and controlled. For the projects such as meter readings, okay. If there's no budget limit, of course, you can choose the LoRaWAN-based gas meters, water meters, or power meters. Well, it's no problem. But sometimes, in some cases or in some projects, the budget is a problem, and infrastructure is also the investment has made. So in order to save time, in order to save the previous investment of the legacy sensors or meters, well, in that case, customers can choose these controllers. That's the best way, the simplest way to save time and cost. Okay, in this recent example, here our customers, one of our customers taking use of the UC1122, the LoRaWAN-based controller with 2 analog input and 2 digital input relay output interfaces for the application of the water leakage monitoring. And customer, they DIY water leakage sensor or detector that based on Raspberry and connect with our UC1122, and finally forward data to his TTN networks and to his own remote monitoring center. And this RS-232 interface on the UC1152 is worked as a conduit or data transparent channel to collect the data from scale and forward to the UG87 LoRaWAN gateway and finally reach to the TTN network server. Well, this case comes from our customer in India. So just take use one RS-232 interface to connect with our electronic scale unit to forward the data physically, and finally switch from the serial port to the LoRaWAN network. And this is another POC testing that organized by our partner Syncotech in Singapore. The UC1152, the LoRaWAN-based I/O controller, the POC integration into Siemens demo site for the cloud-based solution Climatics IC platform that is available for Siemens OEM customers. Here you can see the monitoring environment is an office, and indoor air quality sensors are connected with our UC1152 the controller through the RS485 interface, or we can say the Modbus protocol. And I think that's a physical connection by cable. And UG85, the indoor version LoRaWAN gateway, and I/O controller are registered at LoRaWAN network provider. Okay. So there's a Node-RED to transfer data from LoRaWAN network server to the Climatics IC platform. I want to emphasize the UC1152 can be worked as the RS485 to LoRaWAN converter and Modbus to LoRaWAN converter, or we can say Modbus bridge LoRaWAN. And you can find the same feature in our UC500 series, the sensor node as well, the controller as well. And next, in this case, is a very interesting application, Smart Light Pilot Project. Smart Light Pool is a testing project as well. In this case, we provide a bundle solution of the cellular router and LoRaWAN gateway and the UC11N1, okay, the previous version of the UC500, the controller to monitor the traffic security, monitor the environmental data, and the people counter for building a smart city. Usually, a smart city project starts by installing IP cameras for the public safety or for the traffic monitoring, and end up with a range of deployed IoT sensors. But here in this case, customer taking use of the legacy sensors like the temperature and humidity sensor, like the air quality PM2.5, PM10 air quality sensor, and the people counter as well, and connect to our controller, LoRaWAN-based controller, through the GPIO interface, through the digital input or the analog input RS23245 interfaces, and the controller is solar panel powered. So you can find they are installed in this limited compact space. Okay. So I think the camera, usually I think the camera requires the 4G LTE, the broadband network, and the temperature and humidity, those kind of data, they only need the narrowband network. So I think it's a very perfect combination or balance of these two different networks together. And by the way, our cellular router play a very important role here to give the power to the IP camera and support power to our LoRaWAN gateway, and at the same time taking use of the same cable, Ethernet cable. They can receive data from both camera and both gateway. And in this case, customer is running the business of lending the industrial machine and charge the cost by hours. So they take use of our UC 3322. Okay, this 3G cellular based controller. It works as a timer to capture the operation time of the plastering machine, because this controller is installed inside of the machine's power supply box. So once the machine is powered, the controller is powered at the same time. So customer can take use of their IoT cloud platform. Formerly is the Ursalink Cloud, now is the MileSight IoT cloud platform, to check the offline time, the online period, according to the period to charge the working hours. And smart meter project, this solution contains RTU power meter and the MileSight cellular remote I/O controller UC 3252. This is the 2G based controller. And finally, take use MQTT and AWS IoT platform. The controller enables the communication with power meter and RTU and collecting and transmitting data to the AWS IoT platform and for analyze over the cellular network. And finally, in brief, let's see what we have shared, what we have reviewed in this presentation. Well, in this webinar, we specially discuss the interfaces, what's the functions of the digital input-output or the serial port or the GPIO interface, okay, and what's their how they works, and what models you can find from our controller series, like the 4G based, like the NB-IoT based, and like the LoRaWAN based especially. And controller, in what kind of situations we need to choose a controller, like especially the meter readings, like the power meters, gas meters, and water meters, or if you want to save your budget or save your previous investment, I think the remote I/O controller is the best choice to help you interfacing with other devices to realize the turn on and the turn off. And by the way, most importantly, the last but not the least, the multi-site IoT cloud platform, it works with our UC3 series, the cellular-based, and the NB-IoT-based, and also the LoRaWAN-based UC11 and UC500 series controllers. If you want to set up the trigger, the advanced logic settings in that cloud platform. So I think our customers, you can set up a LoRaWAN environment, okay, take use of this small device to build up a very fast, very convenient environment for testing. Okay, thanks very much, guys. If you have any other question, you can email me or you can forward your message to milesite.com. Okay, thanks very guys. Bye-bye. See you next time.